Bobby places a tennis ball at the end of the spring, compresses the spring, and then releases it, as shown in the diagram. The ball travels horizontally to the right. Q1. Describe the energy transfers that occur from the initial compression until the ball moves. Q2. How could Bob experimentally determine the energy stored in the compressed spring? Q3. What other measurements would you need to calculate the efficiency of this energy transfer from potential to kinetic energy? Q1. As the spring is compressed, the chemical energy from the student's muscles is converted into elastic potential energy. When the spring is released, and the tennis ball starts to move to the right, the elastic potential energy is converted into kinetic energy and some thermal energy due to friction. Q2. To experimentally determine the energy stored in the spring, first measure the spring constant by hanging different masses and recording the displacement from its original length. The spring constant can be calculated using Hooke's law, F equals kx. Next, compute the energy stored in the spring by substituting the values of the spring constant and the compressed displacement into the elastic potential energy formula. Q3. To calculate the efficiency of energy transfer after determining the input elastic potential energy, we measure the mass m and velocity v of the tennis ball to compute its kinetic energy. The efficiency is then calculated as the ratio of kinetic energy, energy output, to elastic potential energy, energy input.